Okay, so if you look at this question, so just now I mentioned already, part A, they try to make use of similar triangle. So the hint is, here we also use similar triangle. Correct, so part A use similar triangle, part B also use similar triangle. Okay, another approach will be, right, I'm going to try to make use of this one. I'm going to try to make use of this one to prove this. And what I did was, the first time I saw was a Pythagoras theorem in this red triangle. Can you see this red triangle? So in triangle ABC, I try to do a Pythagoras theorem. It's a totally not similar triangle approach. So I'm sure all of you can write out Pythagoras theorem. I'm sure you can see that, oh, AB square plus BC square will equal to AC square. Correct. I'm quite sure all of you can understand this. Very easy to understand. So how are we going to marry this equation? I'm going to do a substitution. It's like a bit simultaneous. I'm going to substitute AB square. I'm going to substitute the AB square that I found in the previous part. So I'm going to put in the first formula. So I will get a BC multiplied by BQ plus a BC square equal to a AC square. So I actually try doing this. After I try doing this, right, can you observe you gotten the AC square, and you observe, can you see a common factor? Can you see that BC is a common factor? BC square means BC times BC. So from here, this is the common factor. So remember your basic, take out common factor. So I actually take out BC as a common factor. And this, refer to your diagram. You refer to your diagram. BQ plus BC became QC. So if you do it this way, right, you still get your full marks. But some people may not accept it. They were like, how will I ever know that I need to use a Pythagoras theorem? Actually, it's by trial and error. So I list out all the possible Pythagoras theorem. Because I got more than one right angle triangle. I actually got 3 right angle triangle. I got 3 right angle triangle for me to play around with Pythagoras. So I list out all the possible and I try to marry my answer from part A. So this can be a bit far-fetched, but it is a possible method in plane geometry. So as long as it's supported by a proper theorem and technique, right, you will still get your full marks. So let's say, right, you do a Pythagoras, another student did a similar triangle, all are full marks because you eventually get the proof with the correct theorem, with a proper theorem, with a proper take out common factor technique.